Ladies and gentlemen, here we go. All right, so far, here's what we have talked about in terms of moles, mass, and particles. We know the chemical compound is essentially a collection of atoms. Looked at this a little bit first semester, right? They combine because of the charges or because of how many electrons they need to share or lose or gain. And so you get these compounds, these formulas, right? Like H2O for water, right? And so we know how to count how many we have in each. And we also know how to manipulate this collection of atoms quite a bit, right? We've looked at moles, we've looked at mass, we've looked at particles, we made all these conversions. You've taken quizzes on it, we've done work with it, we'll continue to do more work with it as much as we need for you to be able to understand what's going on with that stuff. Now, we want to talk about this composition conversation, and we want to talk about how we can use some of the manipulating part to be able to look at how people came up with these actual formulas. How do we know this? How do we figure out that there's two of these and one of these and what these formulas are, right? It's not just like I can look at a picture of something and get it under a microscope and see, oh, well, okay, there's those two hydrogens and one oxygen in water. It just doesn't work that way. So in terms of mass, right, not particles yet, but in terms of mass, we're going to look at the composition of something, and then we'll look at how we can use that percent composition later to be able to determine formulas. So right now, let's start with the mass part, and we're going to figure out percent composition by mass of certain compounds. Knowing the composition in terms of mass is important. Later, we'll talk about how you can use data, lab data, to be able to figure this out. But basically, the mass fraction for an element is the mass of the element present in 1 mole divided by the mass of the mole of a compound, which is molar mass. So we'll look at what this means in a little more detail here in just a second with an actual example. But you're looking at how much, right, does that actually make up? So here's ethanol, C2H5OH. It's a type of alcohol, 2 carbons, the 6 hydrogens, and the 1 oxygen. Now, the reason it's written like this is because this OH right here, it's called a functional group. It's what makes something an alcohol. Right? So this particular type of alcohol has these ratios of these elements. Now, percent composition by mass, if I have the formula, I would just assume that I have a mole of ethanol. If I have a mole of ethanol, I have 2 moles of carbon times the molar mass of carbon, which is 12 grams per mole, gives you 24 grams of carbon in every 1 mole of ethanol. In every 1 mole of ethanol, you have 6 moles of hydrogen, 5 and 6. Times the 1 gram per mole of hydrogen gives you the 6 grams of hydrogen in every 1 mole of ethanol. Now, they're carrying this out to a different number of significant figures than we might. It's okay, just pay attention. This is the one you should be copying down on your sheet for the percent composition activity that you're working on right now in Schoology. And oxygen, there's 1 mole of oxygen in every 1 mole of ethanol, 16 grams per mole, 16 grams, right? So that means that the mass of 1 mole of this, or the molar mass of ethanol, is 46.07 grams, or 46 grams for every 1 mole. So here's the molar mass. Here's how much each one of these individual elements contributes to that. So if I'm trying to figure out percent composition by mass for each element, I'm going to take these individual pieces and figure out how much of the whole thing do each one of these contribute, the part of the whole, based on a percentage, right? So knowing the mass of 1 mole, let's figure out carbon. So carbon in ethanol divided by the mass of 1 mole of ethanol, 24, right, divided by 46 times 100, 52%, right? 24 out of 46 is about 50, right? So a little more than 50%. So 52% of all of ethanol's mass comes from those 2 carbon atoms, right? Which you would say, well, wait a minute, there's way more hydrogen, right? But remember, hydrogen weighs less than carbon. So even though there's way more hydrogens, it's actually going to have the lowest percentage, right? All right, let's look at this hydrogen now. The mass of hydrogen in 1 mole, which we figured out to be about 6 grams, divided by the 46 grams, which is the total mass of ethanol again, times the 100 is just moving the decimal, right? Because you're going to get 0.1313, and you're just going to move it over to, that's what the multiplying by 100 is. So 13% of the mass of any sample of ethanol comes from the hydrogen. right? So any sample now, I have this percentage that I can apply that to. Oxygen, okay, we don't need to go through the whole step here, but it's the 16 divided by the 46. So about 34, 35% of the mass of ethanol comes from the oxygen. Now, when would this be useful? Well, if you worked in industry and you needed to get a certain amount of an element from a compound, you would want to pick the compound that has the highest percentage of that element. I wouldn't want to, if I'm trying to liberate oxygen from ethanol and then trap that oxygen, I might not want to use ethanol because only 34% of that, 35% of that whole total mass of that is actually oxygen. I'd want to find a compound where I have more oxygen within that compound so that I'm getting more out of every gram of that substance. All parts should add up to a whole. They should all add up to 100. So you have to make sure that when you're all done that these three all add up to 100, and in fact, they do. Right? So percent composition, we'll look here later, probably not Friday because of the ZAPS training, which is a good thing, but I guess it'll be next Tuesday then because we don't have school on Monday, nice 3-day weekend. So next Tuesday, we'll talk about how we're then going to use these percent compositions to be able to work backwards towards a formula. Because sometimes you'll have a compound, you'll break it down, you'll figure out percent by mass, and then you'll work in the other direction to be able to figure out what the formula of that compound was. And we'll look at how we would do that coming up on Tuesday.